Now let us see the intervals that we use in real numbers. The interval is nothing but a set of particular real numbers, but that can be denoted by a compact notation. So therefore we use these intervals very frequently. Now the first one is what is called as a closed interval. Now let's see what does this mean. Let us consider a real number line having two numbers, say a and b, as shown here. Now in some context, suppose we want to refer to all the real numbers which come between a and b, including a and b themselves. Alright, so the set of all those numbers is called as the closed interval. So to denote it graphically, we darken the two endpoints a and b, and also darken the entire segment between a and b. So here whatever I have highlighted in green, that entire is called as the closed interval. And how do we denote it? We write a comma b in square bracket. So a comma b written in square bracket means it's the closed interval, that is the set of all real numbers between a and b, including a and b themselves. So if we want to write this in the set builder notation, then I can write that it is a set of all such x such that x is real first of all, and x lies between a and b. So I will write a less than or equal to x less than or equal to b. Alright. Now see, I am considering the equality on both ends because I want a and b also to be included in the set. That's the closed interval. Now open interval is almost similar to closed interval, except for the difference that the end points a and b are not included. So that means here, if once again I consider all the real numbers between a and b, but now I don't want to consider the end points, so I want only the numbers which come between a and b. So to show that, what is done is, at a and b we have to show a hollow circle, right? And the region between a and b is highlighted. So that means we want all the numbers between a and b, but the end points, that is the values a and b, are to be excluded. Now here the notation to write open interval is in round brackets. So we write a comma b in round brackets, that means the open interval. And here we can describe it using the set builder notation as, it's the set of all elements x such that x is real and a less than x less than b. So you see here we are not having the equalities on both ends. Now based on open and close, we can have a mixture of both of these together. That means the third type, that is called as either semi-open or semi-closed. Now there is no common convention as to which you call as semi-open or which you call as semi-closed, simply because this is the interval which will be open at one end but closed at another end. So here let us see those two possibilities. The first possibility is that the interval is open on left side, whereas it is closed on the right side. Right? So here you have a and b. Now this is denoted by, since it is open at a, we denote it by round bracket a, then comma and b, followed by the square bracket. So it means it's the interval which is open at a but closed at b. So it's a set of all numbers between a and b. So here we write the set builder notation, that is, it's a set of all such x where x is a real number such that a is less than x but which is less than or equal to b. Correct? That's the way to indicate this. Now let us see the other also, that is, here you have a and here you have b. Now in this possibility we want to include the A but we want to exclude B. Right? So it's closed at left side whereas it's open on the right side. So here we denote it by square bracket A comma B and then closing round bracket. And this again can be written in set builder notation as it's the set of all such elements X where X is real and A less than or equal to X less than B. Alright, so these are what are called as the intervals which we use frequently for real number system.